Today what we're going to talk about is graphing on your calculator. Okay, so we are going to be doing day 11 and 12 within this video. So we're not going to be doing every single problem, but this should get you where you need to. So what we talked about in the past couple days is solving with variables on both sides. So here we have a problem that we've seen before. All we would do is distribute here. Since you cannot simplify anything on the left-hand side, you bring that down. And you distribute the 2x, or the 2 to the x and the 2 to the -4. We still have to simplify just a little bit, so -8 plus 1 is 7. So we'd have 2x minus 7, and then bring down your 3x plus 3. To get our variables together, we move our smaller one. Our smaller is 3x. And you get 3 equals 5x minus 7. Move your 7 to the other side, and you get 10 equals 5x. To get x alone, you would then divide by 5, so your answer would be x is 2. Now, what if I tell you there's a way to do this on your calculator that makes it almost so much easier? Okay, if we go to our calculator, we need to distinguish our y1 and y2 values. So under step 1, it says let y1 equal the left side of the equation, which is this piece right here. So I'll show you where that's at in the calculator in just a second, but we'd have -3x plus 3. And then it says let y2 equal the right side, which is this side, before we even simplify. So it would be 2 parentheses x minus 4 plus 1. So that button is right here. Okay, it's your y equals button. Now what I want you to realize is that there should be plot 1, plot 2, and plot 3 should not be highlighted. Okay, what I mean by highlighted is it would look something like that. If it looks like that, to clear it, you arrow up, hit enter, and then arrow back down. And there should be nothing written in any of these entries. And it goes all the way to y of 10, which is 0. So arrow down to make sure your calculator didn't get messed up within your backpack and stuff was pressed. So what we're going to do, notice we have y1, y2, y1, y2. We're going to type this in just like we see it. -3x. X is right next to your alpha button. It's xt theta n. Okay, there's our x plus 3. Okay, that's our y1. Our y2 would be 2, you arrow down, 2 parentheses x minus 4, close your parentheses, plus 1. Okay, to figure out the graph, you hit graph. If your screen does not look like this, then you probably have to fix your window. To fix your window so it's a standard 10 by 10 screen, you would hit zoom 6. It's our standard screen. Zoom 6. So let's hope that your screen now looks like that. The intersection of this graph right here is your solution. So to find that piece of information, okay, we have to calculate the intersection. We hit second, the button second right here, trace. Trace is up here at the top. Okay, and it brings you to a calculate screen. So second, trace, the number 5, which is intersect. All right, and then you'll see first curve, second curve, and guess. So I want you to press enter 3 times. So 1, 2, 3. This intersection is where those two lines meet. What is your x value? X is 2. So we have a way to, 1, check our answers, or 2, solve problems that we don't really want to do by hand, like this problem at the bottom of the page. If you remember, y1 is the left-hand side, and y2 is the right-hand side. Okay, so we're going to always fill in our values here. 10 parentheses 2 minus x plus 4x. And then -3/10 times the quantity x plus 3. So when we go to our calculator, we go back to the y equals, clear your entries. Y1 would be 10 parentheses 2 minus x, close your parentheses, plus 4x. Okay, always double check that you have written it and typed it in correctly. When we have a fraction, please open your parentheses because we have to put this in parentheses in our calculator. -3 divided by 10, close your parentheses. Open them up again, now we're here, x plus 3, and then close them. If you hit graph, you'll see a graph that looks like that. Okay, now, one thing I'm going to ask you for is what does x equal? Another thing I'm going to ask you for is to tell me a sketch of the graph. Okay, so for this one, we would hit second, trace, 5, and then hit enter 1, 2, 3 times. We're always going to round to the nearest hundredth, which is the second decimal point. So for this one, our answer is 3.67. Okay, I want you to pause the screen and try number 3 on your own. Pause the screen and try number 3 on your own. So far I have graphed the two equations. We need to still figure out what x equals, and we need to sketch a graph. So first we're going to sketch our graph, and our intersection point you can still see on this screen. Okay, so to find it, you hit second, trace 5, enter, enter, enter. And it gives you the intersection of 0.88 because we need to round up. Okay, I'm going to skip all the way down to the bottom of the page for this problem here. When we put this in, again, we're going to need parentheses around those fractions. Okay, so remember one side is y1, the other side is y2. Let's clear our old problem and type it in. Parentheses 4 divided by 3. Close your parentheses because that's your fraction. Open x minus 8. Close your parentheses. And then we would open again for 1/2 and then close and open again for x plus 5. Okay, if you hit graph, what you're going to notice is that your lines do not intersect on the screen. So what we're going to have to do is we're going to have to make this quadrant 1 bigger. In order to do that, you go to Window. Okay, x minimum, notice it's a negatives, that controls how many units you see on the negative side of x. X maximum changes how many units you're going to see on the right side of x. Your scale is 1, which means every tick mark you see on the graph is 1 unit. So because we need to see more of the right side of the screen, I'm going to change this 10 to a 25. And then the same thing for y, negatives, you would see more of the bottom half of the graph, and you would need positive for this side. So we're going to change the y maximum again to 25. So that gives us more of the top half of the graph. So if you hit graph again, you're going to notice that now that first quadrant is bigger, okay? And we can actually see that there is an intersection. So if we sketch our graph here, we would have one line that looks something like that and the other like this. Okay, and then we would need to find the intersection. So second, trace, remember always hit that second button. 5, enter, enter, enter. And our intersection, or x, would equal 15.8. Okay, so a few things we need to know. If you need to see more to the right, we adjust the x maximum, the positive side. If you need to see more of the left, we adjust the x minimum. If you need to see higher up, we adjust the y maximum. And if you need to see lower, we do the y minimum. Now, every time you change your screen, sometimes you're going to need to see more of the left-hand side or the bottom part. We should always reset it to that standard window. And the standard window, remember we hit zoom 6. So let's do that now, zoom 6. Since we've already found our intersection, we don't need this. We'll just have it set for our next problem. So I want you to turn the page. If you notice, you're going to have all of your steps, okay, to solve if you forget. So make sure you keep that. But we're going to move on to day 12. So if you could turn the page to day 12, solving using your calculator special cases. So sometimes you're not always going to have an intersection on the graph. And we've kind of talked about 3 different possible answers to have. We'll get into that later. But first, let's solve this problem. We need to distribute the 2 to 2x minus 10, right? And then we say 2x minus 8. To move our x's together, we would subtract 2x to both sides, and they cancel. So in this problem, we're left with negative 10 equals negative 8. So the question is, are those the same number? If you said yes, we got to look at that again. But if you said no, you're correct. Negative 10 and negative 8 are not the same amount. Okay, so you would possibly say this is a no solution. Okay, but what would that look like on a graph? Okay, so let's actually look at this exact same problem by graphing. So we're going to put y1 as the left-hand side, 2 times x minus 5. And we're going to put y2 as our right-hand side, 2x minus 8. So we're going to go about the same steps as we did before. Okay, so let's clear our last problem out of our calculator. And we would say 2, open your parentheses, x minus 5, and then arrow down, 2x minus 8. And go ahead and hit graph. If you notice that these lines never touch, that's true. Okay, to sketch our graph, we would be left with 2 lines that never intersect. Now, those are called parallel lines. So because you have parallel lines with no touching, they do not intersect anywhere, you have no solution. Parallel lines, no solution. Okay, so I'm going to move down just a little bit more. We're going to go to number 3. Okay, let's try this one. I'm going to put this one right away into our calculator. So 1/2 x plus 9 is your y1, and 1/2 parentheses x plus 18 is your y2. So if we put this in to our y equals, and we clear and clear, we would have parentheses 1/2, close your parentheses, open again, oh, not open again, I apologize, 1/2 x plus 9. And then for y2, here's where we have to open those parentheses again. 1/2, close your parentheses, open again, x plus 18. Okay, if we hit graph, if you have a TI-84 color edition, the CE, you're going to see just 2 lines being graphed on top of each other. You're lucky that you have different colors. For mine, look, it has 1 line, right? So this is what our graph looks like. A lot of times I get, oh, my calculator's broken, it's only graphed 1 line. Well, that's not true. Okay, you have 2 lines graphed on top of each other, which means there are so many intersection points that it's the exact same line. So this would be an infinitely many solutions answer. Okay, quickly I want to draw 3 graphs here. Remember that when you have one solution, you have one intersection point. This is where you need to actually find what x equals. The second situation is when you have parallel lines. If they never touch, you have no solution. And lastly, if you have one line, it's an infinitely many solutions. I hope this helps. You have a quiz soon, so make sure you're watching your videos, and talk to you soon.